In the quiet hours before dawn, as the world still slumbers and the sky is painted with the faintest hint of morning, a different kind of preparation is underway at Vandenberg Space Force Base. Suddenly, a powerful symbol of American strength roared to life, its engines igniting in a blaze of light and fire that split the darkness, marking the beginning of a carefully orchestrated test. Deep within a hardened underground silo shielded from the outside world, the United States Air Force launched an unarmed LGM-30G Minuteman III missile, a silent guardian that has stood watch for over 50 years, quietly ensuring the nation's security. This test, one of several conducted each year, is more than just a technical exercise. It is a demonstration of capability and readiness, sending a clear message to both allies and adversaries about the reliability and effectiveness of America's nuclear deterrent. Even in an age dominated by cyber warfare and digital threats, some pillars of national security remain firmly rooted in the ground, standing ready at a moment's notice to respond if ever called upon. The launch itself is a spectacle of immense power and precision, but the real story lies in the countless hours of preparation, maintenance, and vigilance. It is the dedication of the airmen and support crews who work tirelessly behind the scenes that keeps these systems operational and reliable. Each test serves as a vital health check for a system that must work perfectly every single time. It ensures that both America's allies and its adversaries understand the nation's unwavering defensive credibility and commitment to peace through strength. The Minuteman III is a key part of the U.S. nuclear triad, working in concert with submarine-launched ballistic missiles and strategic bombers. Together, these three legs form the backbone of America's nuclear deterrence strategy, providing flexibility and survivability. These tests are not acts of aggression, but carefully planned and transparent operations designed to verify performance and collect critical data. Each launch is announced in advance to the public and international community to prevent misinterpretation and maintain global stability. For the public, witnessing a Minuteman III launch is both awe-inspiring and sobering, a vivid, tangible reminder of the immense responsibility that comes with maintaining such powerful technology, and the importance of vigilance in a complex world. In a world of constant challenges and shifting threats, this demonstration of readiness offers reassurance to the nation and its allies, reinforcing the message that America remains vigilant and prepared. The silent sentinel awakens, not in anger, but to prove it is still on watch. Steadfast, reliable, and ever ready to defend. To grasp the significance of this test, we must understand the missile itself. The LGM-30G Minuteman III is an intercontinental ballistic missile, or ICBM, named after colonial militiamen ready at a minute's notice. Housed in hardened silos across the American heartland, it forms the land-based leg of the nuclear triad. As a three-stage, solid-fuel rocket, it can launch almost instantly, making it a powerful deterrent. Standing over 60 feet tall and traveling at over 15,000 miles per hour, it can reach targets worldwide in about 30 minutes. The missile's re-entry vehicle, tested here with a dummy payload, is designed to carry nuclear warheads. Though the system is aging, ongoing upgrades keep it reliable until its replacement, the LGM-35 Sentinel, arrives. Each test not only confirms current readiness, but also informs the development of its successor. Launching a Minuteman III is a process defined by precision, discipline, and the highest levels of security. Every step is meticulously planned and executed, reflecting decades of training and technological advancement. It all begins deep underground, inside a fortified launch control center. Here, two highly trained Air Force missileers stand ready at their consoles, prepared to respond at a moment's notice. A launch command, if ever given, comes directly from the President of the United States. Both officers must authenticate the order using secure codes, ensuring that no unauthorized launch can ever occur. Once the command is verified, the silo's massive armored door blasts open, exposing the missile to the sky. Instantly, the first stage rocket ignites, sending the Minuteman III hurtling upward with tremendous force. The entire process, from the moment the command is received to the instant of launch, unfolds in less than 60 seconds, a testament to the system's speed and efficiency. As the missile climbs higher, its three powerful stages fire in succession. Each stage burns for about 60 seconds before separating, propelling the missile further into the upper atmosphere and beyond. Throughout its flight, the advanced guidance system makes constant real-time corrections, steering the missile with pinpoint accuracy toward its intended target. After the third stage burns out, the post-boost vehicle takes over, carefully positioning the re-entry vehicle for its precise descent back to Earth. During test launches, the missile carries a non-explosive payload packed with sophisticated telemetry instruments rather than a warhead. These instruments record thousands of critical data points throughout the flight, transmitting a constant stream of information back to mission controllers on the ground. This wealth of data is meticulously analyzed, certifying the health, reliability, and readiness of the Minuteman III fleet, and ensuring America's nuclear deterrent remains secure and effective. This Minuteman III's journey began at Vandenberg Space Force Base, California, America's premier West Coast spaceport and test range. Missiles are randomly selected from operational silos, transported to Vandenberg, and reassembled for testing. Every component is meticulously checked before the missile is placed in a test silo, mirroring real-world conditions. The launch team includes missileers, maintenance crews, security, weather forecasters, and range safety officers. Weather plays a critical role. Launches are paused if conditions aren't perfect. On July 9, 2025, all elements aligned for a successful launch by airmen from Malmstrom Air Force Base. For the public, it's a dramatic spectacle. For the Air Force, it's the culmination of months of work. The launch validates training, confirms system reliability, and demonstrates U.S. readiness. The journey from Vandenberg is more than a flight, it's a statement of commitment. Each test ensures the nation's deterrent remains credible. After clearing its silo, the Minuteman III soared into the sky, embarking on a journey of over 4,200 miles across the vast Pacific Ocean. This test flight was designed to closely simulate the real-world trajectory of an intercontinental ballistic missile, traveling from California all the way to the remote Kwajalein Atoll. The launch not only demonstrates the missile's range, but also tests its ability to perform under operational conditions. At the peak of its arc, the missile essentially became a coasting spacecraft, following a carefully calculated suborbital path through the upper atmosphere. This phase is crucial, as it tests the missile's guidance and stability in the near-space environment, where it must remain on course without active propulsion. Throughout its 30-minute flight, a sophisticated global network of tracking stations, specialized ships, and military aircraft monitored every move. These assets work together to provide real-time data, ensuring that every aspect of the missile's journey is meticulously recorded and analyzed. After the flight, analysts reconstruct the entire mission, comparing the missile's actual performance to the planned trajectory. They carefully note any deviations, however minor, to improve future tests and ensure the system's reliability. The most critical phase is re-entry, as the test vehicle plunges back to Earth at speeds exceeding 15,000 miles per hour. The intense heat and pressure during this descent push the missile's design to its limits. Its heat shield, constructed from advanced, heat-resistant materials, is engineered to protect the payload during this fiery descent. The shield's performance is vital to the missile's overall success. Engineers and scientists are eager to collect and analyze data on the heat shield's performance, as this information is crucial for improving future missile reliability and safety. The test is conducted with full international transparency, including advance warnings to airmen, mariners, and other nations. These notifications are essential for safety and to avoid misunderstandings. This openness helps prevent misinterpretation of the test and plays a key role in maintaining global strategic stability and trust among nations. Ultimately, the flight is a demonstration of technological power, conducted with responsibility and a commitment to international norms. The Minuteman III's journey ended at the Ronald Reagan Ballistic Missile Defense Test Site, Kwajalein Atoll, in the Marshall Islands. This remote site, equipped with advanced sensors, serves as a safe impact zone for test missiles. As the re-entry vehicle approached, Kwajalein's instruments tracked its final moments, measuring accuracy. The Air Force declared the test a success, confirming the system's performance from launch to splashdown. This success reassures U.S. leaders, allies, and the public of the Minuteman III's reliability. Data from the flight will be analyzed for months, informing maintenance and modernization. Each test certifies the readiness of over 400 deployed missiles. The splashdown marks the end of one journey and the start of ongoing analysis. Why conduct these tests? The primary reason is reliability. The Minuteman III is a complex machine, and real-world launches are the ultimate quality control. Tests provide data that simulations can't, proving the system works as designed. They also validate the training and readiness of airmen, ensuring the human element is as reliable as the hardware. Engineers use telemetry to monitor rocket motors, guidance, and re-entry vehicles, identifying issues before they arise. This information is vital for both maintaining the current fleet and developing the next-generation Sentinel ICBM. Each launch sends a clear message. America's nuclear deterrent is credible and ready. To adversaries, it's a warning. To allies, a reassurance. The U.S. security guarantee is backed by proven capability. A Minuteman III soaring into the sky speaks volumes without words. In today's world, a test like this carries special weight. With Russia and China modernizing their arsenals, the U.S. must maintain credible deterrence. A successful Minuteman III test demonstrates America's commitment to strategic stability. The test is defensive, not aggressive, showing that any attack would face devastating retaliation. Periodic tests keep the deterrent credible and help prevent large-scale war. Transparency is key. The U.S. announces launches in advance, avoiding miscalculation and escalation. This responsible approach contrasts with more secretive tests by other nations. For Americans and allies, the test is reassurance that national security remains strong. Despite global challenges, the U.S. deterrent is diligently maintained and tested. Readiness demonstrations reinforce alliances and confidence in uncertain times. The successful Minuteman III test is more than a technical feat. It's a statement of America's commitment to peace through strength. It confirms the land-based nuclear triad is healthy and ready, thanks to constant vigilance and training. While the Sentinel is on the horizon, Minuteman III's mission continues, bridging past and future deterrence. Each launch provides data to certify the fleet and ensure a smooth transition. In a complex world, a safe, effective nuclear deterrent remains essential. The Air Force's quiet professionals measure success by the fact these weapons are never used in anger. The enduring mission of vigilance and readiness continues, shielding the nation for generations to come.